Okay, now okay. Today I'm going to explain Faraday's laws. Faraday laws, Faraday's laws. Now I'm going to explain Faraday's laws. Faraday's laws. Faraday's law. Okay, so first Faraday first law. Now I'm going to explain Faraday first law. Faraday's first law. First law. So what is the meaning of Faraday first law? What is the definition of Faraday's law? Faraday's law. Whenever magnetic flux changes linked with the coil, then changes with respect to time, then induced EMF or induced current produced in it. This is a Faraday's first law. That is Faraday's first law. So that is a Faraday's first law. Whenever magnetic flux in bracket changes linked with the coil, then changes with respect to time, then induced EMF or induced current produced in it. This is a Faraday's first law. Faraday's first law. That is Faraday's first law. Okay, now I'm going to explain detail in Faraday's first law. In Faraday's law, what will happen? You see that Faraday's law. Faraday's first law. Faraday first law. Now finally, so first relative motion between relative motion between coil and bar magnetic. Next, authorizer changes flux. So next, authorizer induced EMF or induced current set up in a coil. This is finally, so we need finally. So what is the meaning of induced current? Changing magnetic flux will produce induced current. current. Okay, what is the meaning of Faraday first law? Definition of Faraday first law: whenever magnetic flux linked with the coil, then changes with respect to time, then induced EMF or induced current produced in it. That is a Faraday first law definition. Next, Faraday's first law explanation. So, what is the explanation of Faraday first law? You will see here. So, this is a coil. This is what is a coil here. So, in basic point, keep it in mind. Already explained to you. This is an end rule. End rule. This is a end rule. So, what is the meaning of end rule? End rule. Now, basic points. Basic points. End rule. This is a ring. This is a ring. This ring carries current in a anti-clockwise direction. This is a ring. Ring carries current in a anti-clockwise direction. Front ring acts as a north pole. Back ring acts as south pole. This is a one more ring. This ring carries current in a clockwise direction. Front ring acts as a south pole. Back ring acts as north pole. North pole. This is a basic point. This is a we call end rule. We call this is a end rule. End rule. Next, another basic point. This is a this is a ring. This ring. This is a ring. This ring carries current in a anti-clockwise direction. Anti-clockwise direction. Suppose this is one observer. Observer standing here. This ring act as a front ring is act as a north pole, back ring act as south pole. Direction of magnetic field is towards observer. This is a direction of magnetic field. This is a direction of magnetic field. This is a ring. This ring. This is a ring. This ring carries current in a anti-clockwise direction. Direction of magnetic field is towards observer. Towards a observer. Keep it in mind. This is one basic point. Next, one more basic point. This is one more ring. This ring carries current in a clockwise direction. Clockwise direction. This is observer standing here. This ring acts as a small bar magnetic. Front ring acts as south pole. Back ring acts as a north pole. Direction of magnetic field is away from the observer. This is observer. Direction of magnetic field is away from observer. But here, direction of magnetic field is towards observer. But here, direction of magnetic field is away from the observer. Towards observer, away from the observer. This is act as a small bar magnetic. This is a south. This is a north pole. North. Here, this is a north, but this is a south pole. So magnetic lines start from south to north inside. Magnetic lines are moved from south to north inside. But here, magnetic lines are moved from south to north inside. This is the direction of magnetic lines, south to north. That is the two basic points. Keep in your mind. That is very, very, very important. Now you see, this is a ring. This ring carries current in a anti-clockwise direction. Front part acts as north, backside part acts as south. This small ring, single ring, act as a single ring carries current in an anti-clockwise direction. The ring acts as a small bar magnet. Front ring acts as a north pole. Back ring acts as a south pole. Now, next, this is a one more ring. One more ring. This is a one more ring. One more ring. This ring carries current in a clockwise direction. Clockwise direction. This ring acts as a small bar magnet. Front part acts as a south pole. Back part acts as a north pole. North pole. Now you see here very carefully. Same ring I'm keeping here. This is a ring. This ring carries current in anti-clockwise direction. Observer is standing in front of the ring. Direction of magnetic field is from direction of magnetic field is towards the observer. This ring carries current clockwise direction. This ring acts as a small bar magnet. Front ring acts as a south pole. Back part of the ring acts as a north pole. Direction of magnetic field is away from the observer. Away from the observer. You see. On basic point, what is a basic point here? Very, very important. This is a bar magnet. This is a bar magnet. This bar magnet having two poles, north pole and south pole. Now, magnetic field lines will start from north to south. This is outside. But inside is magnetic field lines start from south to north. Now you see here, this is a ring. Ring carries current anti-clockwise direction. This small ring acts as a small bar magnet. Small bar magnet. Front part has north pole, back part is a south pole. Now magnetic field lines start from inside. Inside is south to north direction. South to north direction. This is a line. And direction of magnetic field is towards observer. Here you see, this is a one more ring. This ring carries current to clockwise direction. This ring acts as a small bar magnet. Front part is a south pole, back part is a north pole. Magnetic field lines are start from inside south to north. South to north. This is a direction of magnetic field lines. Direction of magnetic field is away from the observer. Direction of magnetic field is towards observer. This is a basic point. This is a very, very, very important. This is a magnetic field lines. Now I'm going to start the Faraday's law. Faraday's first law explanation. Faraday's law explanation. Now you see, this is a this is a bar magnet, north pole and south pole. Now I'm going to, this is a copper coil. I'm taking that this is a galvanometer. Galvanometer. This is a galvanometer. Galvanometer. This is a galvanometer. Galvanometer can measure current. Galvanometer is used to measure the current. Also. This is a pointer. This is what we call pointer or pointer. The pointer stay at middle point. Now this is a north pole of the bar magnet. This is a south pole of the bar magnet. Now you'll see here. So first, so whenever definition, what is the definition of Faraday's first law? Whenever changing magnetic flux lines. You see. So first point, relative motion between coil and bar magnet. Relative motion. What is the meaning of relative motion between the coil and bar magnet? Means they should be rest. This is a motion. Coil should be rest. Bar magnet is in motion. That is the meaning of relative motion between coil and barmatic. Otherwise, suppose this is a motion, this should be rest. Coil is in motion, but barmatic is in motion. That is meaning relative motion between coil and barmatic also. Otherwise, coil is rest, barmatic is in motion. That is relative motion between coil and barmatic also. అంటే ఇక్కడ ఏంటంటే ఇది రెస్ట్ లో ఉండి ఇది మోషన్ లో ఉన్న రిలేటివ్ మోషన్ ఉంటుంది లేదు కాయిల్ వచ్చేసి మోషన్ లో ఉండి బార్మాటిక్ రెస్ట్ లో ఉన్న this is a motion, this is a rest. We call relative motion between the coil and barmatic. That is meaning. Now next, this is over. This is over. Next, changes magnetic flux. Changing magnetic flux. You can write changing magnetic flux. Changing magnetic flux. What is the meaning of changing magnetic flux? Maybe flux increase, maybe flux decrease. That is the meaning of changing magnetic flux. Changing magnetic. Suppose for example, here this is a coil. This is a coil. This is something. Barmatic flux lines. Now, second barmatic is at this position, not the lines also. Third barmatic is at this position. Now, so what will happen in situation is bring the flux line. Now you will see here, you will see the here what happened in this situation. Here this is a field lines, magnetic field lines. Here also magnetic field lines are also. Here so many field lines are linked with this one. Here at this point, 100 field lines are linked with the coil. Barmatic is, this is a barmatic. Barmatic, not pole of the ball moving towards a coil. Moving towards a coil. Now, initially, position north pole of the barmatic is here, barmatic, and this is another position of the north pole of the barmatic. Less field lines are linked with the coil. This is already field lines. Now, what I'm going to hear, this is a barmatic, north pole of the barmatic. North pole of the barmatic is moving towards a coil. Towards a coil. North pole of the barmatic is moving towards a coil. What will happen? Field lines, magnetic field lines are linked with the coil. Linked with the coil that we call change in flux. Change in flux. North pole of the barmatic is moving towards a coil. So many flux lines are linked with the coil. Increasing flux lines are linked with the coil. Suppose this is a barmatic, this is a coil. Barmatic is at this place. Less field lines are linked with the coil. Next, barmatic is moving towards this direction. Some more magnetic flux lines are linked with the coil. Barmatic is moving towards the coil. Barmatic is very near to the coil. So many magnetic flux lines are linked with the coil. That means increasing magnetic flux lines are linked with the coil. That means change in flux. Change in flux. For example, this is a coil. This is a barmatic. ఈ బార్మాటిక్ ని ఒక మనిషిని అనుకుంటే ఈ కాయిల్ వచ్చేసి ఒక మనిషి అనుకుంటే ఈ బార్మాటిక్ ని మంట అంటే ఫ్లేమ్ అంటే భోగి మంట. దిస్ ఇస్ హ్యూమన్ అంటే ఒక పర్సన్. ఇక్కడ భోగి మంట ఎక్కడుంది? ఇక్కడ పర్సన్. ఈ పర్సన్ కి భోగి మంట దూరంగా ఉంది. ఈ పర్సన్ కి భోగి మంట ఎంత హీట్ అబ్జర్వ్ అవుతుంది? భోగి మంట ఈజ్ వెరీ ఫార్ అంటే చాలా దూరంలో ఉంది. పర్సన్ ఇక్కడ ఉన్నాడు. ఈ పర్సన్ కి ఎంత హీట్ అబ్జర్వ్ అవుతుంది? లెస్ హీట్. అసలు హీట్ అబ్జర్వ్ కాదు. ఈ మంట దగ్గరగా తీసుకొస్తే కొంచెం ఇతనికి హీ ఫీల్స్ సమ్ వాట్ హాట్. మంటని ఇంకా దగ్గరికి తెస్తే హీ ఫీల్స్ సమ్ మోర్ హీట్. అండ్ మంటని ఇంకా దగ్గరికి తీసుకెళ్తే ఈ పర్సన్ he feels more heat and మంటను తీసుకొచ్చి వెరీ నియర్ అంటే మంట భోగి మంట తీసుకొచ్చి పర్సన్ వచ్చేసి భోగి మంట మీద కూర్చుంటే సో మచ్ ఆఫ్ హీట్ హీ గెట్స్ సో మచ్ ఆఫ్ హీట్ అంటే మంట ఎక్కువగా ఉంటుంది. ఇక్కడ మంట మీన్స్ ఫ్లక్స్ లైన్స్, మ్యాగ్నెటిక్ ఫ్లక్స్. ఇక్కడ మంట మీన్స్ ఫ్లక్స్ లైన్స్. ఇది పర్సన్ మీన్స్ కాయిల్ అని అనమాట. అంటే మంట అంటే ఫ్లేమ్ ఈస్ far away from the person. Flame is away from the person. Flame is moving towards the person means the person gets more heat. అంటే ఇది పర్సన్, ఇది మంటను దగ్గరగా తీసుకొస్తే ఈ పర్సన్ కి మంట ఎక్కువగా ఉంటుంది. మంట మీన్స్ ఇయర్ ఫ్లక్స్ లైన్స్. పర్సన్ మీన్స్ ఇయర్ కాయిల్. అంటే కాయిల్ గెట్స్ మోర్ ఫ్లక్స్ లైన్స్. Barmatic, north pole of the barmatic is moving towards the coil means north pole of the barmatic is moving towards the coil means so many flux lines are linked with the coil. That means changing flux. Then induced EMF induced current set up in a coil. Then after here north pole of the barmatic is moving towards the observer. What will happen in this situation? In this situation, so many flux lines are linked with this one, and induced EMF set up and induced current also flowing here. And we are not seeing to this current. The pointer will be deflecting any one of the side. Suppose this pointer moves with the direction anti-clockwise direction means the pointer moves this direction. The galvanometer pointer will be deflect this direction. The two we are finding, what we are finding means okay, in this wire carries current produced in this wire. That is first law. Here induced EMF set up in the coil. Now I'm going to explain one by one point. You see, so what is our target? Target is we want to produce induced EMF in current. Our target is induced EMF or induced current set in a coil. Now we are not seeing to the current in a wire. మనము కరెంట్ ని చూడలేము వైర్, కానీ వైర్ కి గాలోమీటర్ అంటే గాలోమీటర్ లో ఉన్న పాయింటర్ విల్ బి డిఫరెంట్. ఆ పాయింటర్ కింద కదిలితే ఆ వైర్ లో కరెంట్ ఉందని మనం తెలుసుకుంటాం, ఆ వైర్ లో కరెంట్ ఫ్లో అవుతుందని తెలుసుకున్నాం. నౌ వాట్ ఐ హావ్ టు డన్ యు సీ హియర్, ఇది ఒక కాయిల్ తీసుకున్నాం, ఇది కాపర్ కాయిల్. కాపర్ కాయిల్ ఈజ్ ఏ కండక్టర్, ఒక కండక్టర్ తీసుకున్నాం, క్లోజ్డ్ పాత్ లో దాన్ని క్లోజ్ చేసా. నెక్స్ట్ నార్త్ పోల్ ఆఫ్ ద బార్ మ్యాటిక్, దిస్ ఇస్ అ బార్ మ్యాటిక్. ఇక్కడ నేను ఒక కాయిల్ తీసుకున్నా, ఇక్కడ ఒక బార్ మ్యాటిక్ తీసుకున్నా. ఈ రెండింటిని యూజ్ చేసి ఇండ్యూస్డ్ ఈఎంఎఫ్, ఇండ్యూస్ కరెంట్ ని ప్రొడ్యూస్ చేస్తున్నాం. ఇక్కడ దిస్ ఇస్ అ వన్ కాయిల్, కాయిల్ ఈస్ ఏ కండక్టర్, దిస్ ఈస్ ఏ బార్ మ్యాటిక్. ఇది కాయిల్, ఇది బార్ మ్యాటిక్. ఈ రెండు యూజ్ చేసి ఇండ్యూస్ కరెంట్ ని ప్రొడ్యూస్ చేస్తున్నాను, అది కాన్సెప్ట్. అయితే ఈ రెండు కాయిల్ యూజ్ చేసుకొని ఇండ్యూస్ కరెంట్ ఎలా ప్రొడ్యూస్ అవుతుంది అనేది నేను ఎక్స్ప్లెయిన్ చేయబోతున్నాను. ఓకేనా? ఏంటి ఇక్కడ ఐఎమ్ టేకింగ్, దిస్ ఈస్ ఏ వన్ కాయిల్, దిస్ ఈస్ ఏ బార్ మ్యాటిక్. నౌ ఐ కన్సిడర్ కాయిల్ అండ్ బార్ మ్యాటిక్. ఫైనల్లీ we want to produce induced current. ఈ రెండు తీసుకొని induced current ప్రొడ్యూస్ చేయాలి. The two I am going to explain in detail. First of all, the coil should be rested and the bar ম্যাটিক in a motion. Coil should be rest, bar ম্যাটিক in a motion లో ఉంచాలి. Now this is a motion and the bar ম্যাটিক is moving towards this coil. Bar ম্যাটিক is moving towards this coil. So what will happen? Bar ম্যাটিক is away from the coil, means very less flux lines linked with the coil. Bar ম্যাটিক is at this position, some more magnetic flux lines linked with the coil. Next, bar ম্যাটিক is moving here very near to the coil. So many flux lines are linked with the. What is the meaning? Flux increases. Flux increases means changing flux. Changing flux linked, then induced EMF, induced current flows in a coil. Okay, once again I'm going to explain. ఇక్కడ నేను ఏమి ఎక్స్ప్లెయిన్ చేస్తున్నట్టే Faraday's first law లో ఎక్స్ప్లెనేషన్. ఇక్కడ ఐఎమ్ టేకింగ్ కాయిల్ అండ్ బార్ మ్యాటిక్. కాయిల్ ని బార్ మ్యాటిక్ తీసుకొని ఇండ్యూస్ ఈఎంఎఫ్, ఇండ్యూస్ కరెంట్ ని ప్రొడ్యూస్ చేస్తున్నాం. ఇండ్యూస్ కరెంట్ ని ప్రొడ్యూస్ చేయాలి. ఇండ్యూస్ కరెంట్ ని ప్రొడ్యూస్ చేయాలంటే ఏం చెప్తున్నాం? దీంట్లో ఐఎమ్ టేకింగ్ కాయిల్, దిస్ ఇస్ అ బార్ మ్యాటిక్. ఫస్ట్ కండిషన్, రిలేటివ్ మోషన్ బిట్వీన్ ద కాయిల్ and bar మ్యాటిక్. Condition number 1, coil should be rest and bar ম্যাটিক in a motion. Suppose for example bar ম্যাটিক is moving towards the coil, bar ম্যাটিক is moving in the coil. What will happen? And bar ম্যাটিক at this position, a few flux lines linked with the coil. Next, bar ম্যাটিক in the motion at this position, a few flux lines linked with the coil. Bar ম্যাটিক is moving towards the coil, very near to bar ম্যাটিক is very near to the coil. So many flux lines linked with the coil. At this position, very less flux lines linked with the coil. At this position, flux lines linked with the coil. At this position of the bar ম্যাটিক, so many flux lines linked with the coil. That means increases flux lines linked with the coil. Increasing flux lines linked with the coil means changing flux. Changing flux linked with the coil. What will happen? Then induced EMF, induced current flows in a coil. But we are not seeing to the current. But we have to see. Okay. But how do you find out the current flow in a coil? Okay, with the help of galvanometer. Galvanometer having one pointer. The pointer moves in a. The pointer will be deflect in a galvanometer. Okay, the wire carries a current. That current is induced current. That current is a induced current. So first law, what is the meaning of Faraday first law? Whenever magnetic flux linked with the coil then changes with respect to time, induced EMF or induced current flows in it. Okay now, ఏమంటున్నాం ఫస్ట్ లాలో? whenever magnetic flux linked with the coil changes with respect to time, then use EMF or current producing a is induced EMF, induced current. That is induced EMF, induced current అని చెప్తాం. ఓకే, that is a Faraday's first law. Now, ఓకే, అంత బాగుంది. Faraday's first law లో ఫస్ట్ రిలేటివ్ మోషన్ బిట్వీన్ ద కాయిల్ అండ్ మ్యాగ్నెటిక్ ఉండాలి. నెక్స్ట్ చేంజింగ్ ఫ్లక్స్, induced EMF, induced current వస్తుంది. That is a Faraday's law. Now, but I don't know direction here, direction of current. But how can you find out direction of current? డైరెక్షన్ ఆఫ్ కరెంట్ ని ఎలా ఫైండ్ అవుట్ చేయాలి? డైరెక్షన్ ఆఫ్ కరెంట్ ని డైరెక్షన్ ఆఫ్ ఇండ్యూస్డ్ ఈఎంఎఫ్, డైరెక్షన్ ఆఫ్ ఇండ్యూస్డ్ కరెంట్, హౌ కెన్ యూ ఫైండ్ అవుట్? బై యూజింగ్ లెంజ్ లా. లెంజ్ లా గురించి మనం మాట్లాడుకుందాం. ఓకేనా? నెక్స్ట్ ఓకేనా, దిస్ ఇస్ Faraday's law. Now, you see here, next this is a coil, this is a magnetic, this is a north pole and south pole, north pole and south pole, north pole and south pole. Next we have to learn Lenz's law. Lenz's law. Why I'm going to study the Lenz's law? Lenz's law. Why I'm going to explain Lenz's law? What is the use of Lenz's law? Lenz's law gives direction of induced EMF or induced current. Induced current. Now, ఇప్పుడు వరకు నేను ఏం చెప్పానంటే Faraday's law లో ఒక కాయిల్ తీసుకున్నాను. దిస్ ఈస్ ఏ కాయిల్, దిస్ ఈస్ ఏ magnetic తీసుకున్నాను. దిస్ ఈస్ అ రెస్ట్, దిస్ ఈస్ అ మోషన్. అదర్వైజ్ దిస్ ఈస్ అ రెస్ట్, దిస్ ఈస్ అ మోషన్. Motion between the two coils. This bond of the magnetic is moving towards the coil. North pole of the magnetic is moving towards the coil. Increasing flux lines linked with the coil, then induced EMF, induced current flows in a coil. This process is electromagnetic induction. Okay, now what will happen? You see here, what I'm going to explain here. North pole of the magnetic is moving towards a coil. Increasing flux lines linked with the coil after induced EMF, induced current flows in a coil. That is okay. But this coil carries a current. But what is the direction of induced current? My question is, what is the direction of current? What is direction of current? Or not a current, induced current. Okay, Faraday's first law prakaram, this is a coil, this is a magnetic. North pole of the magnetic is moving towards a coil. What will happen? Increases flux lines linked with the coil, then induced EMF, induced current flows in a coil. But what is the direction of induced current? We don't know, but that is the wire carries clockwise direction current, otherwise anti-clockwise direction. That we have to find out. But how can we find out direction of current? By using Lenz's law. So Lenz's law gives direction of induced EMF or induced current. So Lenz's law gives this is based on law of conservation of energy. Law of conservation of energy. It is based on law of conservation of energy. Lenz's law statement. It is opposes to cause, which produce in it. This is a Lenz's law statement. Lenz's law is opposes to cause, which produce in it. Okay. So next, it gives information. It converts mechanical energy to electrical energy. Yes. Signal is bad condition. That's why I'm stopping the class now. Okay. Thank you. ఎందుకు కొట్టాలా చెప్పలే మళ్ళీ చెప్పాలా I'm stopping the class due to bad signal. Okay, thank you very much.
మా 10th క్లాస్ స్టూడెంట్ కి సిగ్నల్ సరిగా లేవడం వల్ల క్లాస్ క్లోజ్ చేస్తున్నాం. మీరు మీటింగ్ వచ్చి తీసుకోండి. మళ్ళీ కనెక్ట్ అయ్యారు, మళ్ళీ మీటింగ్ ఎండ్ చేయండి. మీరు సిగ్నల్ వస్తుంది, ఎందుకు మీకు ఇమేజెస్ స్టార్ట్ అవుతాం.